area equals 1/2 base times height. You could also say length times width, but whatever. For a rectangle, this is technically on the reference sheet, but it doesn't say rectangle. Does anybody remember the formula for a rectangle? Length times width. So area equals length times width. You could also say base times height. Either one is the same thing. Trapezoid, you probably don't know off the top of your brain. So let's look at our formula sheet because that's on there. So if I look at the formula sheet, let's look for trapezoid. 1/2 h, and then in parentheses, base 1 plus base 2. We did this in the beginning of the year. You technically did it in middle school. You probably don't remember, but it's fine. A circle is also on the formula sheet. What's your area formula? Pi r squared. Now, if you look at your blue sheet, your circle formula, your circle section also has some more formulas, because whenever I'm finding perimeter of a circle, can I add up all the sides to a circle? No, because there's no sides. So how do you find perimeter of a circle? You use what? What equation?
The equation that's right there.
No. For a circle, how do we find perimeter? Circumference. So if you look at your circle section on your formula sheet, there's formulas that say C. That stands for circumference, which is C equals 2 pi r. So if it says perimeter, you're actually using circumference. You can also use the other formula that is on your blue sheet, which says C equals pi times diameter. Most people just use this one, so that's the one I always use, but you could use the diameter times pi, same thing. So we're going to do a couple problems, and then this is the only sheet you're getting today. So whatever we don't get done, you are completing, and then you're turning it in online. Because it's a number for our notebooks, you are not turning it into the bin. It is number 24, so you keep it forever, and you're going to turn it in online. So if you need to make a little note, you're going to turn it in online. Number 1, it says using the graph given, determine the area and the perimeter. Usually it doesn't say both, but for the notes, I didn't want to make like a zillion graphs. So we're going to find the area and perimeter for each graph. So this is a triangle. Let's start by finding perimeter. So we have to add up the sides. So this is a vertical line. I can just count that. So how much is the distance from E to F?
8.
1, 2, 3, 4, 5, 6.
No,
It's 7.
Okay.
It's 7.
Okay.
At the bottom, this is what you're talking about. How much is from F to G? 8. Okay. Because those are straight lines, and what I mean, technically all the lines are straight, but like it's vertical and horizontal, you can just use your eyeballs and count them. Okay. But whenever it's diagonal, you could use Pythagorean theorem, but we're going to use the distance formula because it's not always a triangle. So we're going to, but you could technically for the triangles use that. But for this, we're going to use the distance formula and we're going to type it into Desmos. So for EG, I want to use a different color. So EG is a little Akko Taco. It's sideways. It's crooked. So we need to use the distance formula. We used the distance formula before. So can anybody tell me where E is out on my graph? 2, 9. And then where is G at? 10, 2. And then the distance formula is on your blue sheet. I'm going to write it at the top of my paper. So if you look at your blue sheet, find distance formula. It is the square root of x2 minus x1 squared. Squared. And then plus y2 minus y1 squared. So we are going to plug in our values. Remember, if I leave my classroom and I walk to Duncan, it is the same distance if I start at Duncan and I end up at my classroom.
What if you run?
It's the same distance.
If you run there, no, if you walk there and then if you run in,
It's the same distance.
But you take more steps.
It's the same distance.
Same distance.
Okay. Anyways, so it does not matter which one is coordinate point 1 and which one is coordinate point 2. So if you look at your blue sheet, you're using the distance formula. We're going to plug in the numbers and then we're just typing it into Desmos. As long as you type it in correctly, it's going to pop out the answer for you. So it's on your blue sheet. So what is x2? 10. I'm minusing x1, which is how much? No. 2. I'm doing y2, which is 2, and I'm minusing y1, which is 9. Use your blue sheet. Your blue sheet has the formula.
Wait, is that work? Is it
What?
the little two? The work?
No.
Yeah, that's what you said.
Yeah, you get a decimal. That's the whole point.
Oh.
So sometimes it could come out to be a whole number, but in this case, it's a decimal. Remember when you're typing this in, you need the radical first. So let me clear this because this is the first time we're doing it in class. You need the square root first, and then you have parentheses. You're doing 10 minus 2. It's easier if you just type it using like the keyboard. Parenthesis. Oh, don't forget your exponent because I just forgot my exponent. Yeah, that's what you should do. Shh, be quiet. That's great. Okay, so once you have it typed in, you should get a decimal most of the time. So if I'm rounding to the nearest hundredth, we're going to use 2 decimal places. This would be 6.3. So we're going to say this is 10.63. So 10.63. I'm going to put it on my picture. We're going to do perimeter and we're going to do area. So perimeter, like we said, we add up all the sides. So off to the side, and when you're doing this, you don't have to write this all out because I'm teaching you. I'm going to write it all out. But whenever you're doing this, you don't have to do this all like written out. 7 plus 8 plus 10.63 gives me how much? 25.63. Whenever I'm using area, because it's a triangle, I'm using a specific formula. What's my formula for area? Base times height. What's my base? 8. What's my height? 7. Can you stop? Seriously, stop. So if I multiply those, what do I get? 28. Not 20. 28. Is it 28? Yeah, okay. I'm just making sure. Sorry. Like second guessing myself now. So for each one that we do, we're gonna find both. Normally just ask for a perimeter or area, so just read the problem. So it's not that bad. As long as you have decimals up, like it's pretty easy. Let's do the next one. Next one is a rectangle. Now, are any of the lines in my rectangle perfectly horizontal or perfectly vertical? No, but we know something about a rectangle. We know the top and the bottom are equal, and we know the sides are equal. So do I need to use the distance formula 4 times? Twice. Because it's not a square. If it was a square, I could use it 1 time because all the sides are equal, but this is a rectangle. So the top and bottom are the same number. The sides are the same number. So I'm going to have to do the distance formula twice. So let's start with the top. So I'm going to use X and Y. I'm not going to use Y and Z. You could use Y and Z, but Y and Z are further away from 0, 0, and they're negative. So I don't really want to deal with the negatives. So I'm going to use the positive numbers. So let's use X and W. So X is where on my graph? 3, 2. And then W is where on my graph? -3, 0. We're going to call this X1, Y1, X2, Y2. A lot of people, whenever they're doing the distance formula, if you mess up, because realistically, distance formula is super easy, especially if you're using decimals. The only thing that a lot of people will do, and it's not even a lot, I would say like 20% of you will just call this. They're like, this is coordinate point 1, so I'm going to call this X1, X2, and I'm going to call this Y1, Y2. I've seen this a lot. Okay, the coordinate point has X and Y, so you cannot do that. Each one, and it doesn't matter which one's X and 1. So take a second, you're gonna write it in the formula, and then you're gonna plug it into the calculator online. Let the calculator do the work for you, so you don't have to. So you should be doing -3 minus 3 for your x's. Because it's x2 minus x1. And then over here, you're doing 0 minus 2. That's not right. Good. 6.32. If you may have forgot the negatives. There's always a minus sign in the middle. So it should be 6.32. So the top and the bottom of the rectangle, because the rectangle has matching sides, are 6.32. I'm going to do the same thing with either the left or the right side. Think about this a little bit. It technically doesn't matter which one's used. Which one's going to have less negatives, the left or the right? The right. So let's use the right side. X is still being used. X is still 3, 2. It has not moved. Where is Y on my graph? 6, -7. That's okay. So this is x1, y1. This is x2, y2. This is very like random, weird. Not this question. But this, it's literally the same thing. Okay, so take a second. You're going to plug it in. So we're doing x2 minus x1, y2 minus y1. Why are we doing what?
Why are we using that?
Because we have to do like one of the sides. So we either have to use XY or we have to use WZ.
Can you go for it?
Yeah. So when you plug this in, what do you get? 9.49. Did you put a plus sign instead of a minus sign? Okay, we'll double check because you messed up somewhere. So 9.49 is on both sides because it's a rectangle that have matching sides. We're going to do both. We're going to find the perimeter. How do you find perimeter? Add up all the sides. So take a second. You don't have to write it all down. I'm going to write it down just in case. Some people literally just mindlessly copy everything I write, which is fine. If you know how to find perimeter, you don't really have to write it down. If I add up all 4 sides, how much do I get? Good, 31.62. That's correct. How do I find area? Good. Multiply length times width or base times height, whatever you want to call it. So area, we're going to use length times width. So it doesn't really matter which one's the length, which one's the width, because either way, you're just multiplying them together. So don't get tripped up. People are like, which one's length and which one's width? Oh! Doesn't matter. Okay. So what do we got? Something big. What is it? 59 point what? So since it's 976, that's gonna be 98. I didn't hear you. You were like mumbling. That's why I was like, what? Oh no. Okay, the next one doesn't have a picture. We have a bunch of coordinate points. It says if the vertices of a trapezoid are blah 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 blah, determine the perimeter of the trapezoid. So we don't have to find area, just as perimeter. Okay. So take a second. Let's plot our points. It should make a trapezoid. So it's gonna look a little weird because it's a trapezoid. A is 0, 0. That's smack dab in the middle of the graph. B is at 6, 0. So just go over 6, plot a point. C is at 4, 4. D is at 2, 4. take a second, think about there's sides that you can just literally count. You don't have to use the distance formula all the way around. What's one of the sides I can just count? The top and then the bottom, because they're just straight lines. So I can literally just go. So how much is the top automatically? 2. How much is the bottom? 6. So we already have the top and the bottom of our picture. Now, if I look, I need to actually calculate these because they're crooked. Okay. But what do you notice about those sides? They are the same. So do I have to do it twice?
Yes.
No, I do it once and then it matches. This is technically an isosceles trapezoid, meaning the sides just match. So I'm going to do the distance formula one time. Do you want to use A to D or C to B? C to B, sure. It doesn't matter. Both are in quadrant 1. So honestly, both are positive numbers. It doesn't really matter. So I'm going to use C and B because that's what I heard most of. So C is at 4, 4. B is at 6, 0. So this is X1, Y1. This is X2, Y2. Take a second, try to set up your equation. Try typing it into the computer. Get your decimal. Sometimes they can be whole numbers too, so don't freak out if you get a whole number. What's that? You don't have to. What away when you don't have and like finish my mind. So you just need to put everything to do. It's not. Okay, so when we plug that in, what do we get? 4.47. This is easy, right? Do we feel okay? Sure. I mean, it's not like annoying to type it, but like, take your struggle. What's up? So the only thing you're doing wrong is your square roots and how your square root stops. Everything needs to be under the bracket. So at some point, you accidentally went first. Okay. You have to keep going, and then. I think somebody. Okay. So we're gonna find the perimeter because all it says is the perimeter. So perimeter, what am I gonna do? Add them all up. So what do I get? No. Yes, 16.94. So you're doing 2 plus 6 plus 4.47 plus 4.47. So you should get 16.94. We're going to do one more together because it's a circle and I know it's going to blow your mind. And you're like, oh, yeah. Okay. Oh, 2 plus 6 because it's the top is 2. The bottom is 6. So when you're adding the perimeter, you're doing 2 plus this, plus this, plus this. You have to go all the way. Huh? Anytime you wait, what? Yeah. Well, you just put that in. Like you draw the picture and then you pick which side you want to use. Yeah. I don't. It's fine, but. You gotta go across the other side. Okay, last problem is a circle. So. Number 4 says determine the perimeter in the area of the circle. So if I'm going to find perimeter of a circle, which sounds super silly because you can't add up the sides, what formula am I using for a circle? 2 pi r because it's actually circumference. Circumference. I feel like I spelled that word wrong. I might be, whatever. Circumference is 2 pi r. For area of a circle, what's my formula? Area. Pi r 2. Okay. Do I need the distance formula for this? No, because I can't use the distance formula because it's a circle, so there's really no distance. I need to figure out the radius. So if I look at my circle, find the center. Find the center of your circle, and then you're going out to the side. So if I find my center, that's your dot, and you're going out to the side. And technically, you could go to the left, you could go to the right, you could go straight up, straight down. Technically, it doesn't matter, but from the center out to the side is 5. So all I need to do is plug this in. So in your calculator, you can actually which we should have used this whenever we did 3D shapes, but I'm a silly goose and I was still on like summer mode, so I wasn't thinking properly. You can literally just type this all in here. You don't even have to like really do the math. You're doing 2 times pi times 5. So in your calculator on Desmos, you don't even have to like do it in the calculator. 2 times pi. Where the heck is pi? It's on here somewhere. Oh, it's right here. If you don't have pi, then you are on the wrong Desmos calculator. You probably typed Desmos into the search bar. You should go through Canvas and go through modules. When you're doing area, same thing. I would use Desmos. Area is pi times 5 squared. When we did this in class, we had to memorize that you were doing exponents, but Desmos knows that you have to do that. So I should have taught you with this, my bad. What's it, 78.54? 78.54. So on module 2, part 2 test, it's literally just this and then 3D shapes. So next week, we're just going to practice 3D shapes and then your test on that, which is like kind of random, like why this active is angles, but whatever. So you have 3 problems. You do not have to do area and perimeter for these. Number 5 says area. That's it. Number 6 says perimeter. That's it. 7 says area. You have plenty of time. You have like 20 minutes. I would just get them done. Take a picture of the back and put it on Canvas because it's Friday and I know you're going to forget and it's the weekend and everybody wants to brain rot over the weekend. You know,
What?
everybody just wants to
I
like
can't say.
sit in your bed and die and just marinate into your pillow. Okay. So do your 3 problems now and take a picture of it and put it online. And that way you're done. Okay. Let me know if you get stuck. Let me know if you need help. One of the square roots is a whole number, so don't freak out if you get a whole number on Desmos. Someone's out. When they get back, you can go. Okay.
I know
What's up?
You told me to keep things until after I took my test.